All right, let's get right into it. If you're serious about landing a top-tier job in software engineering, there's one thing you absolutely cannot ignore. We're talking about the DSA imperative. And yeah, your journey really needs to start today.
So let me guess, sound familiar? You know data structures and algorithms are important. You've probably told yourself a dozen times, okay, this week I'm starting for real. But somehow, tomorrow just always feels like a better day to begin. Well, stick with me for just a few minutes, because what we're about to unpack might just be the push you've been waiting for. Seriously, this isn't just about code, it's about shifting the entire trajectory of your career.
So, what is it? What's the deal with this big hurdle that holds so many of us back? Let's just call it what it is. The starting problem. It's this super common cycle that, it starts with the best intentions but almost always ends in total panic.
We tell ourselves these convenient little stories, right? Oh, I know the basics. Yeah, I've watched a bunch of tutorials on YouTube. And the classic one. I'm going to get serious about DSA right after I master just one more language. And then, bam, reality hits you like a ton of bricks. The interviews are scheduled, placement season is here, and suddenly it's absolute panic mode.
And see, that panic isn't just a temporary feeling. It leads to something much, much bigger. The consequences isn't just stress, it's what I call the great career divide. It's a massive fork in the road that can literally define the rest of your professional life.
Look, the tech job market is basically split right down the middle. On one side, you have service-based companies. They need you to know some basic coding, syntax, the fundamentals, and the pay reflects that. But on the other side, you've got the product-based giants, the Amazons, the Googles, the Microsofts. And what's the gatekeeper? What's the one thing you have to know to get in? It's right there, in bold, advanced DSA. The real shocker, though, is the huge gap in what you get paid. Let's really put that into perspective.
So this is a pretty typical starting point in the service-based world. It's a respectable start for sure, but it's only half the story. And this is where you start on the other path. The difference is just staggering, isn't it? We are talking about a 3, 4, even 5 times multiplier right out of college. And this isn't about being lucky, it's about having a very specific skill.
So here it is, the hard truth. You can have 10 programming languages on your resume, but honestly, the top companies, they don't really care. What they care about is how you think, how you tackle a problem, how you break it down, and most importantly, how you find the most efficient solution. And that way of thinking, that's exactly what DSA teaches you.
Okay, I know what you might be thinking, but DSA is so hard, it's just a bunch of abstract theory. Let's just throw that idea out the window right now. The problem isn't the subject, it's how it's usually taught. So we're going to try something different. We're going to start thinking in pictures.
And this is the core of it, right here. So many of us get hit with these dry, academic definitions that make these concepts feel impossible to grasp. But here's a spoiler alert for you. DSA isn't actually that hard. It's just taught really, really badly. Let me prove it to you.
Okay, forget that textbook definition for a second. Just imagine a train. A linked list is like a train. The head is the engine. Every piece of data, every node, is a train car. Now, if you want to get to the very last car, what do you have to do? You've got to walk through every single car in front of it, one by one. You can't just magically appear in car number 7. That's a linked list. Simple.
Now, let's compare that to an array. An array is like a huge numbered parking lot. If I hand you a ticket for parking spot number 50, you can drive straight there. You don't have to check spots 1, 2, 3, all the way to 49. You just go directly to your spot. That's called direct access. See the difference? With a simple picture, it suddenly makes perfect sense.
And this way of thinking applies to performance too. Think of it like a race. Your slow runner is using a brute force approach, like nested loops. In fancy terms, we call that ON squared, which just means the work gets exponentially harder as you add more stuff. But the fast runner? They're using a smarter tool, like a hash map, which we call ON. Their work grows in a straight, predictable line. In a real race, the ON runner would lap the other guy almost instantly. That is optimization. And that is what these big companies will pay you a ton of money for.
Okay, so we get the why, and we've got a new way to think about the how. But what about the what? What do you actually need to do? Well, you can't just wing it. You need a roadmap, a real strategy.
This is probably the biggest mistake I see people make. They go on a site like LeetCode, see there are thousands of problems, and they just freeze. They're completely overwhelmed. But here's the secret. You don't need to solve every problem. You just need to learn the underlying patterns that solve most of them.
And here's a proven way to do it. Think of it as a 100-day workout plan. For the first 15 days, you just build your foundation. You get really comfortable with efficiency, arrays, and hashing. Then, for about a month, you master all the linear stuff, linked lists, stacks, queues. Then comes the big challenge, the gatekeepers, things like trees and graphs. And finally, you spend the last chunk of time on advanced optimization. See, it's a marathon, not a sprint, and this map keeps you from getting lost.
And while you're on that roadmap, your real focus isn't just on the data structures themselves, but on these problem-solving patterns. These are like your Swiss Army knife, reusable techniques that just keep showing up in interviews. Once you really, truly get the logic behind something like sliding window or two pointers, you'll start seeing them everywhere. This is how you go from just memorizing answers to actually understanding how to build solutions from scratch.
Now, we have to talk about the elephant in the room. We live in an age of incredible AI. So, is all this hard work even worth it anymore? Is this skill actually future-proof?
It's the question everyone's thinking about, right? If an AI can just spit out code in 2 seconds, why would I spend months learning how to solve these problems myself? And you know what? It's a totally fair question.
And here's the answer. AI is an amazing tool. It can generate code, sure, but it has no idea about the consequences of that code. It might give you a solution that works for 10 people, but will completely crash the system with 10,000. Your job as an engineer is changing. You're not just a coder anymore. You're the architect. You're the optimizer. You need that deep DSA knowledge to look at what the AI made and say, is this efficient? Is this scalable? Is this even correct? This skill makes you the pilot, not just a passenger in the plane.
So let's end on this thought. The path is tough, no doubt, but it's also incredibly clear. And if you decide to start today, if you really commit to this process, you're not just studying for an interview. You are building a foundational skill that will anchor your entire career. And trust me, one day, a junior developer is going to look at a piece of your clean, efficient code and ask, "Wow, how did you get so good at this?" And you'll know exactly how to answer. You started today when everyone else was still putting it off until tomorrow.